basically here to distinguish between an analog and digital image. So we'll start with analog image and then proceed towards digital image. So what is basically an analog image? Analog image is what we see around us. Everything around us is analog in nature. For example, photographs. Have a look at the image here. It has L length and H height. Between this point and this point of length L, it can take infinite number of points, because between 2 points there are infinite number of points, and same goes for the height H. There are infinite number of points here and infinite number of points here, and these infinite number of points can take infinite number of values. For example, let's assume this picture takes a minimum. So since these two are again two numbers, and between these numbers there can be infinite number of values, so there are infinite number of points in this image, and these infinite number of points can take infinite number of values. So infinite storage space will be required to store such an image, and basically such an image contains infinite number of information points. So what we try to do when we try to digitize an image is we'll try to reduce the image information so that storage and processing becomes easier, because it is not practically possible to store infinite amount of information. Here a benefit of analog image is highlighted, that is, analog image contains more information than digital image. So when we try to digitize it, what we are doing? When we are trying to digitize it, we are limiting the amount of information, that is, convert this H height into a finite number of values. For each element there will be a fixed column and fixed row, and it's not continuous, so there are gaps, and it's still going from the range 0 to H, but it's taking finite number of values, it's not taking infinite number of values. So here it's taking finite number of values, here it is taking finite number of values, and the intensities values can also be from a set of finite values. So basically we can thought of a digital image as a matrix, that this image can be represented as a matrix which has a finite number of elements. So basically converting this image into a matrix involves two processes. The complete process is called as digitization, that is conversion of the analog image to a digital image that can be represented in the form of matrix, which is shown here. And the digitization process consists of two processes. First, sampling is carried out, then the quantization. For sampling, basically we mean that there are this matrix representation in which F00 there are finite number of rows and finite number of columns, and what we mean by quantization is that each matrix element can take finite value, means that it can take values from a set containing finite values. So one benefit of digital image was highlighted earlier, that the storage is easy. Another benefit can be that infinite copies can be made without compromising with the quality of an image. For example, when we consider analog image, the quality degrades when we try to make copies. For example, you can think of like a photo. For example, you can think of photostat. You're repeatedly taking photostat of the photostat will degrade the quality, more black and black will appear. While in a digital image, no such problem occurs, because the information is represented in numbers, finite numbers, values. So I hope with this video you are clear with the difference between analog image and digital image. Analog image is basically for viewing purposes, and digital image is basically for processing, storage, and for exchanging information easily.